Hello and welcome. Rahul, you're watching my YouTube channel of my talks, and if you're watching me consistently, welcome back to my channel. Sometimes I try to disseminate positive knowledge, and in order to have deep insight, it is essential and important that we should have basic knowledge of physics, And today I'm going to deliver that basic knowledge, as a capsule so that you can understand where the front end physics are going on and what we are searching. So if we talk about physics, we have to understand what and how our universe was created, At the time of Big Bang, when fluctuation happened, it was a big blast, people, physicists say. And when the universe got created, it was hot plasma, it has photons. Later on, it got cooled down, and Higgs symmetry breakdown happened. I will tell you about it, Higgs symmetry breakdown, what it is. And then particles got created and matter got existed. But beyond that, if you want to know, in initial stage, particles were cancelling each out. Particles got created in that plasma and they were cancelling each out. You know about matter and antimatter. The same is true with the particle and antiparticle. So what happens when Higgs symmetry broke down? Particles got created. Photon does not have mass, but particles have. But when they met antiparticle, they got annihilated because the charge and the same mass, when charge is opposite and the same mass they have, they will cancel each out and they will release energy as per equal to mc square, Einstein equations. Energy and mass relation that has been described by Einstein. So what happened? If we talk about particles really, then we have to know which kind of particles our physics describes and what has been invented until now. When we discovered that fundamental building blocks are atoms, then we knew that this could be the smallest particle. But beyond that, when we looked into atoms, we found that electron, proton, and neutron makes them. But later on, when the science got developed, we still divided, proton and neutron, because proton and neutron are also made of quarks. That have fractional charges. Protons have +1, but within that it is made of 3 quarks, and quarks have fractional charges, +2/3, +2/3, and -1/3, cancel out and becomes -1. That has what got proton. But when we talk about neutron has neutral charge, zero charge. But within it, quarks have certain charges which cancels each out and it gives neutral charge to it. So we understood. So the quarks are of especially 6 type. One is up, up, top, up, top, and another is that is called char. And when one is down, tight down, strange, and bottom. These are the 6 quarks family that makes particles, particles of matter particles. So matter particles are also called fermions. They are made of quarks and leptons. I told you electrons, proton, and neutrons. Later, proton and neutron got divided into 6 quark, suppose, and then electron. So fermions, means matter particles, are made of quarks and leptons. Leptons have certain type. That one is electron, one is muon, one is tau, one is another one is existed. Right now I'm forgetting that, but there are 4 types. So these are the particles that have been defined for matter, matter particles. Another are force particles, force particles that we also have to know in order to understand physics. And force particles are of, suppose this is electromagnetic field, then it creates photon. I will tell you about, initially we will have knowledge that when you will place a magnet, it will have magnetic field. When you bring a charged particle, it will have electric field, in modern physics. When you will bring, planet, it will have gravitational field. But this is in modern physics, But when we talk about quantum field theory, it sees that actually fields are more fundamental than that of particles. Fields are more fundamental than that of particles. And they say that fields actually creates a vibration, and its topmost vibrations are particles. That is what field theory says. So later we will discuss. First we understand what kind of fundamental particles are there. Total there are 17 fundamental particles, 6 type quarks, and 6 types lepton, and 5 types force field. Force field, if we talk about the electromagnetic force, it will have electromagnetism will have photons. One is weak force, nuclear force. One is a strong force. One is Higgs boson, which is very vital. Higgs boson, when it was invented at CERN in 2012, it blows out the mind of many physicists, and they called it, even Higgs boson, they call it God particle. But many physicists do not agree with that. But the fundamental thing is that Higgs boson, this field gives masses. This field, Higgs boson, is the particle that is created by Higgs field. And it actually, the Higgs boson is the reason for Higgs field. And it actually gives masses to the particles. That is why it was called God particle. But later on they discard it. Still the theory is going very deep. So we knew exactly these 17 fundamental particles. And we knew the quantum mechanics, how it studies all these, and how quantum mechanics brings a lot of solution to our world. But later on, quantum mechanics solve the problem of studies the quantum particles and solve the problems of quantum mechanics. And general relativity theory brings gravitational and universal gravity. They studies that, but it created problem when they wanted all together. They brought a string theory, because this was creating to unify that. They brought string theory, but later on they found that string theory is not enough. So they brought supersymmetry, and supersymmetry theory along with the string theory became superstring theory, and that is what is right now is going on in physics. So string theory actually says that these particles are small vibrations, and they have certain length, and in that wavelength hidden dimension exists. So he talks about extra dimensions, and string theory tells about that. And supersymmetry tells a different thing. That every matter particle has its relational force particles. If we are matter particles, we have force particles. Small at quantum level, we have force particles. I have told you already what are force particles, and what are matter particles. This is what it tells. And without supersymmetry, the string theory does not give the right answers. So superstring theory came, and right now the research is going on. So we knew that these are the building blocks. And at CERN many scientists studies these particles. And they try to bring new theories. New when they collapse the matter, then the particle collapse. When they have antiparticles. So they release energies. We knew that. So every particle has antiparticle. Antiparticle. And in supersymmetry, every particle has force field particle. So these are the two different things, not antiparticle and not, these are different things. That is what we have to know. So if we study physics, we will understand exactly that mysteries are very deep, and it is time to solve everything in the world. Thank you for listening to me.